Okay, this video tutorial looks at the mathematical strand of linear and non-linear relationships, and more specifically it focuses on solving simultaneous equations by substitution. So the first thing you need to know is how to solve simultaneous equations by substitution. Well, the first thing we need to do is we need to replace one of the variables in the equation with the equation that's actually equal to that variable. So for example, we have two equations here. We can see that in our first equation, we know what y equals, because y equals 3x take 2. Alright, so now we need to rewrite our second equation, but we need to substitute that value back in for y. So this second equation over here ends up becoming 5x take 2 lots of 3x take 2 equals 5. All we've done is we've replaced this y here with the value for y. Now we can just solve it because we've got one variable. So now it becomes 5x take 2 lots of 3x, which is 6x, take 2 lots of minus 2, which is actually plus 4, because minus 2 times minus 2 is positive 4, and that's going to equal 5. Now we can collect the like terms. 5x take 6x gives me minus x, plus 4 equals 5. I can take 4 from both sides. Minus x equals 1. Therefore, I can say that x equals 1. And if x equals minus 1. And if x equals minus 1, I can then substitute the x value back in here to find out my y value. So I end up with y equaling 3 lots of minus 1 take 2, which equals minus 3 take 2, which equals minus 5. So therefore my values are x equals minus 1 and y equals minus 5. If I put those back in, it should work. So let's just check. If I put these values back into this equation here at the start, I should have 5 lots of minus 1 take 2 lots of minus 5 should equal 5. 5 times minus 1 is minus 5. Minus 2 times minus 5 is plus 10. Minus 5 plus 10 does in fact equal 5. Therefore, I'm correct. So let's have a look at another example. Again, here we can see that we know what x is, because x equals 2y plus 4. So all I'm going to do is I'm going to substitute that in to where the x is. And when I rewrite this equation, I get 7 lots of 2y plus 4 take 5y must equal 1. Using the distributive law, I can expand this out and I go 14y plus 28 take 5y equals 1. I can collect the like terms, which are the minus 5y and the 14y, and I can say minus 14y take 5y gives me 9y plus 28 equals 1. I can take 28 from both sides, and I end up with 9y equaling minus 27. Divide by 9, divide by 9, I get y equaling minus 3. Now, as y equals minus 3, I'm going to substitute back into my original equation to find out what x is. X, therefore, is 2 lots of minus 3 plus 4. Therefore, x is going to be minus 6 plus 4, and x is going to be minus 2. So I have an x value of minus 2 and a y value of minus 3. To check whether these work, let's put these into my original equation here, which had both variables. And I get 7 lots of minus 2 take 5 lots of minus 3 must equal 1. 7 times minus 2 is minus 14. Minus 5 lots of minus 3 is plus 15. And minus 14 plus 15 does equal 1. So therefore, I'm correct. Okay, so let's see how you went. Now remember, in this equation, the first one, it tells me what y is. Y is actually x plus 5. So what I'm going to do is I'm going to substitute that into here. So that leaves me with 3x take x plus 5, because that's what y is, and that's meant to equal 1. Now this minus here, this minus belongs to both of these. So when I rewrite it, I end up with 3x take 5 equals 1. Collecting the like terms, I end up with 2x take 5 equals 1. When I move, or if I add 5 to both sides, or if I move it across, I end up with 2x equaling 6. Divide by 2, divide by 2, x equals 3. Now what I'm going to do is I'm going to substitute that back into this equation here. And I end up with y equaling, we know x is 3, plus 5, so that gives me 8. So I end up with x equaling 3, y equaling 8. They're my solutions. I'm going to put it into here just to see if it works. 3 lots of x, which is 3, take 8, which is y, must equal 1. 3 times 3 is 9, 9 take 8 does equal 1, and therefore I'm correct.